Hello, let me now discuss what is uniform distribution, derive the mean and variance of a uniform distribution, and also solve this simple problem to understand the application of the uniform distribution to problems. But actually speaking, we have got better problems in uniform distribution. I will introduce first what is a uniform distribution and the simple application. Then in the coming days I will take up tougher problems which are really very effective and really which are applied to real life problems. Okay. Now we know, see, we define a random, this is a continuous random variable. See, a random variable x is said to follow uniform distribution. See here, AB is said to follow uniform distribution, that is uniform distribution defined in AB, that is it is defined in the interval A to B. This random variable is defined only in the interval A to B if PDF is given by fx of x is equal to 1 by b minus a less than or equal to x less than or equal to b, 0 otherwise. So in all other places the random, that is the probability density function is 1 by b minus a for in this interval. The probability density function is only there. For other places the probability value of the probability density function is 0. So this is the definition of a uniform distribution. Now what is E of x? See, E of x is equal to, it is integral of, it is a to b of x into 1 by b minus a into dx. Because the probability here, if you want, I can write one more step here. It is fx into dx. This is the probability density function. So this is equal to a to b x by b minus a into dx, that is 1 by b minus a into x squared by 2, that is equal to, it is b squared minus a squared divided by b minus a plus b plus a into b minus a divided by 2 into b minus a, that is equal to b plus a by 2. So E of x let us find what is sigma of x squared. See, we know that sigma of x squared is equal to E of x squared minus E of x whole square. Now E of x squared is equal to, it is again a to b x squared by b minus a into dx. So this is equal to 1 by b minus a into x cubed by 3, that is equal to 1 by 3 b minus a into, it is, apply the limits, a to b, it is b cubed minus a cubed, that is equal to b minus a into b square plus ab plus the a square divided by 3 into b minus a, that is equal to b square plus ab plus b square by 3. Therefore, sigma of x squared is equal to b square plus a square by 3 minus b plus a whole square. See this one, e of x whole square is b plus a whole square by 4. So this is equal to 1 by 12. It is 4a square plus 4b square, then plus 4ab minus a square minus, it is minus 3a square minus 3b square minus 6ab. So this is 4a square for 4b square plus 4ab, it is minus 3b square minus 3a square minus 6ab. So this is equal to, you see, it is 1 by 12, 4a square, this is a square, and this is 4ab, this is minus 2ab plus b square, which is equal to b minus a whole square divided by 12. So this is that. So this is what we get. Now, so this is a very simple calculation, we can just find out. Now let me go to the problem. What is the problem given here now? The problem is that x is a uniform distribution defined in the interval 2 and 6. That is, x is a uniform. See, x is a random variable. X is a random variable that follows uniform distribution interval 2 7. So this implies fx of the probability density function of it is equal to 1 by 6 minus 2, that is equal to 4. That is, this is like this. See, it is 2, 6, something like this. See, this is it is defined like this. Now we are asked to find what is e of x. E of x is equal to 1 by b plus a by 2. So this is equal to 6 plus 2 by 8 by 4, that is equal to 0. Variance is equal to b minus a. It is 6 minus 2 whole square divided by 12. This 6 minus 2 is 4. 4 square divided by 12. That is 4 fours are 12, 3 fours are 0. So this is. Now to find what is, see, p of 3 less than or equal to x less than or equal to 5 is equal to 1, 3 to 5 fx into dx. But here this is uniform distribution and the PDF is this one. Your PDF, this is your PDF. So this is equal to 3 to 5. It is 1 by, see, 1 by 4 into dx. That is equal to 1 by 4 x into 3 to 5. That is 1 by 4 into 5 minus 3. That is equal to 5. Therefore, so this is all. See, there are some, we can, as I told you, I have introduced what is called a uniform distribution. I have defined what is a uniform distribution. This distribution is also very much widely applied in problems. I'll take up difficult problems or the real application to the application of the uniform distribution to real life problems. We let us take and discuss afterwards. This is all about this. I'll deal with more difficult problems in the coming days. Thank you.